Hi, here we are talking about chapter 12.3, equations of lines for vectors. And now we're going to determine if they're parallel, they're skew, or do they intersect. Well, here's some common things to know about that and how they you can find out quite easily. If they are parallel, they will have a common scalar multiple. If the two lines are skew, then they will have no common multiple, and two of the equations will be satisfied, either x and y or x and z, y and z, something. Two of them will be satisfied, however, the third will not be. And that will indicate that for some reason those two vectors, that when you look at them from far away, they might look like they are actually intersecting as these two pens do. But if I turn, now all of a sudden they don't intersect because they're on two different planes. See how I did that? It's magic. Okay, so they will have a third direction that is not consistent to where they would intersect. So those would be skew. Finally, if they do intersect, they will have no common multiple, but all three of the equations will be satisfied to where you can find a point of intersection. All right, so in this video, what we're going to do is we're going to go through parallel and skew, and the next video we'll talk about intersection and finding that point of intersection. All right, so here we go. Here we are. Example number 1. Show that line 1 is parallel to line 2. So we get x is equal to 2 minus 3t. We get y is equal to t, and z is equal to negative 1 plus 2t. For line 2, we get x is equal to 1 plus 6p, y is equal to 2 minus 2p, and z is equal to 2 minus 4p. And when we're determining whether they're parallel or not, we're not too concerned necessarily about the initial point as much as we are the direction vectors. Similar to two lines that are linear equations. They could have different y-intercepts, but if they have the same slope, then those two lines would be parallel. So what we're going to do is we're going to look at the direction vectors of each. We notice that this direction vector is negative 3, 1, and 2. And this direction vector for line 2 is 6, negative 2, and negative 4. So if we look at those two direction vectors, we look to find something that could be in common. Can I multiply one of them and get the other? And we'll notice is if we do multiply this line 1, this set of direction vectors with a negative 2, it will result in a 6, negative 2, negative 4. And so, yes, we can conclude that those two lines are in fact parallel, or those two vector equations are, those two vector lines are parallel. All right, so let's go on now to find out if they are skew or not, and how do we do that? Well, if we come over here a little bit, if you notice that we have example 2, it says show line 1 is skew with line 2, and we see that x equals 1 plus 4t, y equals 5 minus 4t, z equals negative 1 plus 5t. Now for line 2, we get x equals 2 plus 8p, y equals 4 minus 3p, z equals 5 plus p. And we treat this basically like systems of equations. We find two equations, either x and y or y and z, something, we match them up and we add. Now in some cases you might have to multiply one to get something to cancel. And we're looking to do the elimination or substitution method. And in this case, we notice that this 4t and negative 4t will cancel. So we get 1 plus 5 is 6. We merely add this side, so 2 plus 4 is 6. 8 minus 3 is 5p. And if you do the arithmetic, you'll notice that if we subtract 6 and that gives us a 0, so P is equal to 0. Now solve for T, so we simply substitute that value in. We have 1 plus, I just chose the top equation, 1 plus 4T is equal to 2 plus 8 times 0, and what happens is when you get that, you get, if we bring the 2 over, or I bring this 1 over, subtract 1 from that, we get 4T equals 1, and algebraically then we'd end up with T is equal to 1/4. Now what we want to do is finally substitute that into the third equation and ask ourselves, is the equation satisfied? And you can see that -1 plus 5 times 1/4 is not equal to 5 plus 0. So in this case, two equations can be satisfied, but the third is not satisfied. So I urge you to rewatch this, go back through it, do the math yourself, and find out, again, just practice it a little bit and see if you can determine, once again, that they are skew on your own. All right, so again, common multiple, parallel. No common multiple, two equations satisfied, but the third is not, skew. And the next video will be based on intersection, where there's no common multiple, yet all three equations are satisfied. All right, hope that helps. Have a great day.